that thermochemical equations report the change in enthalpy for a given reaction stoichiometric terms, right? So now we're gonna press a little bit because remember, neuroplasticity. If you work, if you're struggling, you're gonna learn more. You're gonna create more, neural connections over there. So when 1 mole of potassium chloride crystals decompose the potassium chloride crystals and the oxygen gas at a constant temperature and pressure, 39.9 kilojoules of heat is given off. See the term is giving off. That means you're releasing this energy, right? Release. So it's an exothermic reaction, right? So let me just grab a pen over here. So here. So here, first I'm gonna write down the reaction. So I have potassium chlorate, right? And the solid is because it's crystal, and it's decomposing in potassium chloride, which is solid as well because they say crystals over here, and oxygen gas, right? So we need to balance. We have oxygens over here, so we're going to put 3 and 2, so I have 6 oxygens over here, but now I have 2 potassium, so now it's well balanced. So what I'm going to do here is only to write the thermochemical equations, right? But here, look at this. They say that for 1 mole of potassium, we have 39.0 kilojoules. So in thermochemical equations, it's important to know that the enthalpy listed is specific to the molar quantity given. So when you look to the balanced reaction over here, I have 2 moles of potassium chloride. So that means my enthalpy change would be minus 2 times 39.0 kilojoules, okay? Because I don't have 1 mole, I have 2. So by my enthalpy here will be 78.0 kilojoules, okay? So in here they ask how many moles of oxygen are produced when 125 kilojoules of heat are given off. So we know that they ask you minus 125 kilojoules, right? Given off, so exothermic reaction, so it's giving away, it's releasing energy. I know that for 2 moles of potassium chlorate and 3 moles of oxygen, I have negative 78 kilojoules. So negative 78 kilojoules for 3 moles of oxygen, because they are asking me how many moles of oxygen are produced. So I'm going to multiply this by this and divide by 78, right? So, and I'm going to have 4.0876 moles of oxygen. So here, 3 significant figures, 3 significant figures, 3 significant figures. So we're going to have here 3 significant figures. So we're going to be 4.81 moles of oxygen. Good? Not hard, right? So let's go to another problem. Let's practice more. Here says, based on the following equation, how much heat is released by burning 28.5 grams of methane? So it's a well-balanced equation. So I know that for 1 mole, I will burn 890.4 kilojoules, right? So what I'm going to do is, I have mass, I need moles. So mass of methane. So if I want the moles, I'm going to divide by molar mass, right? So 1 mole of methane is 16 point, let me see, we have carbon, which is 12.011 grams, right, per mole, and we have hydrogen, which is 1.008 grams per mole, so we need to multiply this by 4 and then add this, okay? So we're gonna have 16.042 grams of methane. So we're gonna cut grams with grams, so we're gonna have moles. And I don't need to do this, so we can go directly over here. So we're gonna multiply. I know that 1 mole of methane, because they're asking you energy, right? So how much heat? So 1 mole of methane, I release 190.44, right? Kilojoules negative. So how much I'm gonna have here in energy? So for this quantity of for this mass, I'm gonna have negative 1581.16 kilojoules. So I have 3 significant figures, so should stop over here. So we're gonna have 160. Oh, sorry, no, it's too much. 158 kilojoules. So I have 3 significant figures. Okay, easy. So first you convert mass to moles, and then you use as unit factor what you know. You know that for 1 mole of methane, I release 890.4 kilojoules. Second question is, what is the mass of oxygen that needs to react to produce 1193 kilojoules? So now I want 1000, release it, so 1093 kilojoules. And I know that 2 moles of oxygen, right? Oh, over here, look, 2 moles of oxygen is release 890, let me erase this, 890.4 kilojoules. So since I want mass, I'm gonna use molar mass. So I know that 1 mole of oxygen is 32 grams of oxygen, right? That is molar mass. Okay, this is molar mass that I'm using to convert moles to grams. So we're gonna cut units over here, gonna end up with grams. So we're gonna have 85.7502 joules of kilojoules of oxygen, right? So another kilojoules, I'm sorry, grams. I have energy in my head. Grams of oxygen. So since I have here 4 significant figures, and here 4 significant figures, here 4 significant figures, so here you're gonna have 4 significant figures, so 85.75 grams of oxygen. That's it. That's all.